Okay. Hello, everyone. Welcome to Cloud Native. If anyone is watching this on the live stream, we heard a big roar, so I think England just equalized. I'm not sure. No spoilers. We have two talks for you tonight. The first, architecting safe autonomy. I've been told to skip the rest of this intro. It's very long. And then putting Open GitOps to the test. This is us Cloud Native. And we are a strong, open, diverse developer community dedicated to cloud, data, and AI in London. I'm Steve Pereira, formerly of Just Eat here. Cheryl is in Australia and sends her regards. Talks. Okay, and we have a couple of sponsors here tonight. If anyone wants to step up, we have Octopus Deploy with us. Don't want anything slides.
It's always a good start to get up without tripping over the stage. So I'm very happy that I've managed that. Yeah, we're very happy to sponsor this event. I was on a live stream with Cheryl recently, and I think she's doing a cool thing here with this event. Octopus is a deployment tool. So if you're deploying stuff, we help do that. We try to make it as smooth as possible. We kind of want to focus on the CD side of things. So that's our gig. We want to we know there's lots of CI out there. We're actually really into CD very specifically. And we do both deployments and runbooks, and we kind of help you to remove some of the roadblocks in the way of your change getting to production. So we're here to smooth that out. But I won't talk about it loads, but you're very welcome to come and talk to me afterwards if you want to find out more. And I've dropped some stickers out there as well. Thank you very much.
I don't think we have anyone from Luther Systems. A little bit about TechShack. They're a tech recruitment agency specializing in the cloud, engineering, and AI. TechShack exists to build high-performing tech teams by putting community, connection, and quality first. We will skip on here. And I don't think that we have... Oh, is this ship? Sorry, excuse me. There are no slides up. Well done. Yeah. There you go. It would help if you could see the slides. No, that's the wrong ones also. There we go. Much better. Okay. So I don't think we have anyone from the sponsor here, but Chronosphere, absolutely built for the AI era. I won't read off the slide because I know how exciting that is when people do it. Yeah. If everyone wants to try for the polling, we have QR code and questions for you. I'll give you a few minutes. Okay, let's see how we're doing. First time at Cloud Native. Well, most of us are regulars. Good. And catching up. 50-50. Yeah. Okay, well, all the people here for the first time, it's a pleasure to meet you. Yeah. Let's see what else we got. Job title. Lots of other. Cool. We have some DevOps platform engineers in the house. It's nice to see. And some backend developers. Okay. I'm really curious about what other is now. I'll have to like talk to you later. Okay. What percentage of your production systems are run on Kubernetes? Okay, it's always a difficult one, but there's a fair amount of Kubernetes knowledge in the room. It's always nice. Okay, and when you give an AI agent real autonomy, what worries you most? I see no one is worried about over restricting it. Okay. Oh, one person, just to be contrarian. Okay. Interesting. All right. Okay. Now, oh, yep, selfie time. My bad. We'll try and do it from this side of the room. Get everyone in. Yeah, okay. Yeah. See, I'm gonna get up. There you go. Big smiles. Cheese. Okay. We get a couple of those. Excellent. All right. And so, yeah, if you do want to speak at Cloud Native, please sign up. We have speakers open from 2027. Always excited to hear new voices. And I don't know if we have questions coming in for these. I tell you what we'll do. Let's skip straight to the first talk. Over to you.
Yeah. Okay. Yeah. This is working too. Okay, great. Okay. Hi, everyone. I'm Hossein from Luther. I think it's still 1-1 last I checked. So this is about architecting safe autonomy. And I know that some of you are very technically oriented. I'm not. So be gentle with me. So this is about basically architecting safe autonomy, which is designing high stakes autonomous agents with deterministic checkpoints. So the more freedom we give an LLM, the more capable it is, and but at the same time, the more it drifts. So it can do multi-step reasoning, tool use, and just difficult tasks, but it starts making stuff up. It violates policies, it makes incorrect assumptions, and it definitely prefers speed over completeness, which means that it will just propagate the errors to get to the end. But if you restrict the agent too much, it just loses its capabilities. If you lock it down too much, it loses its reasoning and autonomy, and you're basically just building a workflow with a chatbot. Something happened. Okay, this is like the perfect time to give this talk. So what we discovered is, I can go fast and we'll just get to the game. What we discovered was we should stop policing its thoughts and start grounding in reality, which basically means that we shouldn't micromanage the reasoning. We should just Can someone just check what the score is? We need to crystallize its progress through milestones instead of policing it too much. Can you hear me now? Is it better? Okay. Is it better now? Okay, good. So the idea is to basically create, what we did was to create deterministic checkpoints. So we let the conversation roam free and get to it towards its goals, but crystallize it at specific checkpoints and milestones and validate those milestones. An analogy that we often think about is you can think of it as a Brownian motion versus a Brownian bridge. So a Brownian motion, if you leave it, it'll just continue its volatility and drift further and further. But with a Brownian bridge, you can say you can still behave that way. Just remember in the future, at a certain point, you need to be at a specific point. Outside of that, you can do whatever you want. So the application we built this method for was agentic infrastructure setup. Now, to set this up a bit, in the way we saw it, every layer has an agent apart from one. So code obviously has super famously Claude and Codex and Brilliant and underlies most of the rest. UI lovable, application builder, Firebase, Replit, deploy, Vercel does a fantastic job. And this is a very short list. There are many, many wonderful applications that do this, but infrastructure setup seems to be missing. Now, the way we see it, this is hard because it's high stakes. It's difficult to change. It's high impact. It's quite costly and it's security intensive. And it's high barrier. So it's quite specialized and quite intimidating to touch anything. You might mess it up and it's just difficult to deal with. So what we wanted to do is, from a user's point of view, describe, basically the user wants to see this. Describe the goal, add any constraints they might have, talk it through with the agent, like a whiteboarding session, and at the end, get a fully deployed infra. We messed this up in many different ways, but two of them was, at the beginning, we said, okay, we know what the components are, so why don't we basically just almost make this a questionnaire? The problem was that users hated this. So we gave it autonomy, and I'm not kidding, it literally started talking about Inside Out movie. So inspired by that, we used the usual stack of UX, agents, rules, knowledge, memory. But the relevant part here is that it had two agents, Riley and Hippo, which are the user interface and the reasoning agent. But on the other side, it had Guard and Wisdom, which is a set of rules and how to enforce them. So we let the conversation and the questions and the challenges by the user be autonomous, but we said there are deterministic checkpoints at milestones. Set of features, stack, config, cost estimate, and the terraforms. They are deterministic checks. So during a milestone, the conversation just roams autonomously. At the end of the milestone, we generate a deterministic artifact based on the conversation. We validate that artifact. It either validates or it doesn't. If it doesn't, the agent basically goes back to the user, takes what failed in a very natural conversation, reminds the user what's wrong, and together it basically nudges the user to go back to fixing that problem. But not in a, here's a list, you failed here, in much more of a conversation and suggestion-wise. But ultimately, it won't pass this milestone until the problem is fixed. Now, each milestone has its own set of checks. These are just samples. Basically, like for example, for stack, the most important checks are, do we support these components? Are they addressing the issue that the user has? And three, are they compatible with each other? Basically, is this a consistent stack? So, and again, basically, you stay in one stage until the stage passes all the checks. So to summarize this part, what we did before was We gave it too much autonomy, that was a disaster. We gave it too much structure, people hated it, several other ideas. But this method of giving it freedom but checking its work along the way basically detected issues locally. It allowed the agent to stay creative. It stopped the error from compounding because it wouldn't let the agent pass a stage without its checks, and the failures were legible and simple enough for the agent to communicate to the user. And we think that this approach applies to any multi-stage agent. So I have a video here, this is about like 4 or 5 minutes, that shows what the agent is doing in practice, and it emphasizes the stages.
I decided to build a small AI-powered summarizer for meeting transcripts. Now, I'm at the point where I need some back-end infrastructure for it, but that's not really my comfort zone. Let's get started. We'll press proceed, and then we'll choose our preferred cloud provider. And we're met with this agent, which is what we're going to use to build our infrastructure. And we'll say, my meeting schedule is out of control, and keeping track of everything that gets discussed is a constant struggle. I'm building an AI-powered note-taking app for transcribing meetings. Small scale, just for personal use. Inside Out gets back to us with a list of features that best suit the needs of our application. A simple web dashboard, audio upload and storage, AI-powered transcription, automated summaries and action items, and searchable meeting history. This is the first milestone in the process, which you can see in this progress bar in the top right. You can tweak the feature list here, then once you're happy with it, Inside Out checks it and agrees. Now we've finalized the features, we're going to the next milestone, which is to build the stack. Inside Out will go through the features one by one, suggesting stack components. And once it's done, it's going to check the stack again to make sure it all works together. For our first feature, a simple web dashboard, it suggested S3, CloudFront, and Secrets Manager with a justification for each. You can also see that our stack has started appearing here by component category. This looks good, so let's approve it and move to the second feature. For audio upload and storage, Inside Out has suggested S3 Lambda and an API gateway. I'm not sure why it's chosen Lambda, let's ask about that. So it's chosen Lambda over a traditional virtual server because it has a $0 baseline and zero maintenance. I'm still not sure. What would the advantages of a traditional server instead be? And Inside Out has told me the pros and cons of each. Traditional virtual server would let me upload longer recordings, but would cost more. So I'm happy with its choices. We'll stick with Lambda. I'm going to go through the rest of the features building the stack, just like we've been doing here, and I'll see you after that for a summary. So, this is our full stack suggestion for all the features, and it's asking us to confirm our stack before moving to the next step, which is configuring that stack. Solidifying the stack is a milestone in the process. Milestones are how Inside Out avoids issues in your infrastructure that could cost you time and money later. At each milestone, Inside Out generates a deterministic artifact, like a JSON file, which is then checked against a set of rules, and then the chat resumes. These checks could be making sure components are compatible with each other or whether Luther supports the stack component. So Inside Out has been checking my stack against a set of rules, and it's asking me to proceed, which means the stack passed the checks. If it hadn't passed, Inside Out would give me suggestions to nudge me towards fixing the stack so it can pass these checks. This flexibility lets Inside Out build functional, safe architecture without just becoming a questionnaire. Let's proceed. Stack is done, and while we were building it, Inside Out was collecting info to suggest a configuration that it estimates would match our needs, and then it suggests this to us. Here's our configuration, our scale, our storage settings, our region. Again, you can question or tweak these config details. Once you're happy with the config, Inside Out runs its checks again, and if they fail, the chat will explain the config problem to me and help me fix it. The boundaries between milestones also mean that downstream steps aren't affected if there's an error here. It will be fixed before we ever get to those steps. The agent stays creative and errors stop compounding. This config looks good, so we can complete config and move to the next milestone, which is cost estimate. Inside Out generates a cost estimate based on components and usage, which you can see for this stack is $38 a month. You can also see it broken down by category here. You can then question and tweak this. Even steps like the cost estimate are being checked before you proceed to the next step. Inside Out is asking me if I want to proceed, which means the cost estimate phase is done, and we can go to the next milestone, which is generating Terraform. Our Terraform files are ready, and you can preview them by pressing the Terraform button, where you can see them broken down by component. And when you've reviewed the Terraform, Inside Out does one final check. And now I'm being prompted to deploy, which means it's passed all the checks. So now, just press Sign Up to deploy. Now is when you need to sign in or sign up, because this is where you are committing and deploying your real infra in your environment. Now just press Apply Terraform and it will start deploying. This will take about 2 to 20 minutes, and I'll see you when it's done. And that's deploy successful. Now we can see the fully deployed infra in the management screen. Here you can see all your components organized into folders, which represent component groups with cost breakdowns at a glance. Nothing is hidden in extra menus, and you can reopen the chat to discuss at any time. Here, you can edit, view, adjust, troubleshoot, and monitor your infrastructure in full. And that's Inside Out, from designing infrastructure to deploying it.
And I need to figure out how to go to the next. There we go. So this is already in production with a number of our customers, but much more importantly, it's also embedded inside some of the IDEs that everyone's used to. So seamlessly, you can just work from inside your favorite environment and just use this to deploy your infra. So that's it. So we're hardening safety with hardness rules at intermediate checkpoints. Everywhere else, the agent is actually autonomous. Thank you.
Thank you very much. So we are running a little bit ahead of time, but I don't know if we want to go straight into the next one, Steve. Okay, so we have putting open GitOps to the test. Actually, I don't know. That's a good question, but we have lost.
So we've actually tested it. It works very well, but it's very slow. Like it does actually surprisingly well in detecting everything. It just takes a long time to fix. There's so much in like, yeah, exactly. What we say, experience. This is as in like scanning the whole thing or changing something.
Oh yeah. Sorry. So the example is if I've got lots of resources in my AWS account and one of those resources is hitting a limit, for example, the number of SMSs I can send. I'm typing with the tool. Would it be able to identify and then resolve that?
Yes. So it actually does surprisingly well with those kinds of issues. The most important part is the most challenging part of this agent is to prevent it from making stuff up or suggesting stuff that don't exist or you don't approve or doesn't support. So it's actually very capable, but also very imaginative. And the hardest part is getting it not to go out of bounds and start imagining things and suggesting stuff is like, no, but we don't allow that, or we can't afford that, or.
Cool. And then with your multi-step pipeline, is it possible to say before the deploy step, instead of taking that Terraform and running it into AWS yourselves, just take the Terraform and put it into our GitHub repo for
Definitely,
us to review.
In fact, it's free until you deploy it. You can actually do this, go on there and actually do this, and just download the Terraforms and never tell us.
Cool. Thank you very much.
Do we have any other questions? Okay, I think that's a no. So a round of applause, please. And over to Steve.
Thank you. I just find somewhere to slide my laptop over here. Give me 1 second. Space has appeared. Thank you. Although it is tempting being able to present wirelessly with no HDMI cable. You know, when guitarists have got like the wireless and they can like go around. So maybe I'll just come out and present from out there. Okay. Cool. So today I want to talk about GitOps. And I suppose my first question is, has anyone heard of GitOps before? Or it's quite a few people? Cool. If you haven't put your hand up, don't worry. I will introduce the concepts as we go. If you have put your hand up, what I'm going to do is put a GitOps to the test. So we're going to see if GitOps is worth doing. So my name's Steve. I work at Octopus Deploy. I've written a few books. I am a researcher and a DevRel. And I also work with the CD Foundation and with Dora, who you may have heard of from the State of DevOps report. Not the State of GitOps report, that's a different one. From the State of DevOps report, the State of AI-assisted software development. But the State of GitOps report is the one that I'm using for today's presentation. It's data that we collected to find out if GitOps works. So, what is GitOps? If you didn't put your hand up, this bit's for you. The idea behind GitOps is instead of going and fiddling around with our infrastructure, which can sometimes go wrong, and it's kind of hard to know where you are, we will instead operate against files that we've got in version control. So we can change a text file to say that we want some change made, and it will magically happen. And the best definition for this comes from OpenGitOps, which is from the Cloud Native Computing Foundation. And they've boiled it into 4 principles, which is kind of cool. This is available on opengitops.dev. And if you are near the front of the room, you'll see this is version 1.0.0. If you're at the back of the room, it's probably version 100. Sorry about the text size, but it boils down to these 4 things. It's declarative, versioned and immutable, pulled automatically, and continuously reconciled. Easy peasy, right? We'll all rush back to our desks and make this happen. I should probably explain, just in case you don't know. Declarative means that we say what things should be rather than the set of steps to get there. So this is the difference between declarative would be environment control, where you say the room should be 20 degrees. Keep it at 20 degrees all the time. Just make it happen. And if it gets warm, it'll cool it down. If it gets cold, it'll warm it up. But all you care about is 20 degrees. Instead of having a set of instructions saying, if you notice it's getting hot, go over here and switch this on. If you notice it's getting cold, switch that off, turn the radiators on. Versioned and immutable, easy peasy. Stick it in Git. You can use other version control providers as well. It doesn't have to be Git. But is anyone here using something other than Git? I'll stop talking about it then. Cool. Pulled automatically. This means that you need something that will go and pull your latest version of things in Git. And then continuously reconciled means it takes what it's pulled and it makes it happen in real life. So that's GitOps in a nutshell. Not too tricky. So this is what it looks like in a graph. So you have something checking that desired state, looking at the current state, and then changing it to be like the desired state. Simple as that. So a nice simple reconciliation loop. Something that traditionally we've done manually. It's like, why is there only 1 server in our web farm? Oops, there's supposed to be 5. Then you go and change it. Well, that's going to happen automatically with this. So when I first heard about GitOps, I was kind of like, kind of sounds a bit weird. I wonder if that's plausible. And then I realized this is kind of the traditional way that we've done things in software. We kind of react. How do we feel about GitOps? How do we feel about this new thing that people are saying? And then I realized I needed to invoke curiosity and ask the question, does GitOps actually check out? And to do this, we create a hypothesis or many hypothesi. I'm going to make that the collective noun now for hypotheses. So yeah, we have some hypothesi. We write them down first because we don't make them up after we've got data. We put them in first. We then design a survey, and we design interviews, and we design other tests that we can do. And we go and collect all of that data, and then we test the ideas that we had to see if they hold. Sometimes they do, sometimes we're surprised, and we're happy either way because we're learning. So that's what we went out to do. We went to check out GitOps. This is just to impress you with some color. The idea is we got 660 responses in total. Not all of them were usable. Sometimes people respond weirdly, and we have checks in there to help us identify weird responses. And sometimes we get responses from people who maybe aren't valid people to answer our questions. For example, if someone is a chef, we might not want to take their response and tell developers what they should do based on what chefs do. But we did get a good range of experience. So everything from people who are just starting out in their career, all the way through to people that have been doing software development for 35 to 40 years. And I'm sure they have some really cool war stories as well from doing that. Lots of industries, lots of different areas of the world. So we're not just getting a single view of this, we're kind of getting a global view. And that's super important because we don't want to kind of go out and go, this is what people in London think GitOps is like. We want to know from everyone everywhere. And then we drew this model. Not by hand. I used Drawio for this, but it kind of looks it's done by hand. The boxes over on the left of the diagram are things that are related to GitOps, kind of things that you can do. So we've got there, you'll notice some of these look like those open GitOps principles, declarative desired state, version control, automatic pull, continuous reconciliation. We were also curious about a few other things to do with this. One is human readable formats. There are some tools out there that don't give you a file that you can just open and look at. They kind of compile to some kind of binary, and they still work in a kind of GitOps way, but you can't look at the file underneath. So we wanted to test that out. And because you're sticking this into version control, we wanted to know how long it took to get your pull requests approved. Was it 5 minutes or 8 minutes? That's what we wanted to know because they don't take very long. We then have the green boxes. And these are cool things. These are things that Dora have proved really well through their research. So software delivery performance, you may have heard of the 4 keys. They measure throughput and stability. Come and speak to me afterwards if you want to know the secret 5th key. We have reliability. A lot of people don't realize that Dora has more than the 4 keys. They have some really cool reliability metrics, and they have some well-being metrics because it's kind of nice if we can enjoy our lives and enjoy our work. Yeah, makes me sound like a hippie, but I think it's true. Also makes companies more profitable. So you don't have to be a hippie. You can be a capitalist and still want people to be happy. So we wanted to know, do those things over on the left help these things? Because we already know from the Dora research that those things help organizations do cool things. And that's what we want. Organizational performance can be money. It can also be other goals. Your goal might be to save the bees, right? So whatever that is. So that's what we're going to test in this research. We're trying to make it as scientific as possible. And we turn those things, those white boxes, into a score. It's one of the easiest things you can do. You add up, do you have declarative state, yes or no? And we can give them some points for that. Is it in version control? Yes or no? And give them some points for that. Take all of those factors and score them. Some of them are yes or no. Some of them are how long does it take to do a pull request? That's not really yes or no. And then of all of those 660 responses, these are the scores that people got. And it kind of distributes across. There's like a kind of scattering over in the disappointment area. There's loads of data points in the middle. And then there's a few at the top. So a good distribution of scores, which means we can cut this up and say, is there something different for the people at the bottom of this graph to the people at the top in terms of those outcomes? And we did a very simple slice. We said 25-point ranges, If you score 75 to 100, yay. If you score 0 to 25, we'll be kind and call that pre-adoption so that we don't kind of make you feel like you're a bad person. And then we looked at what relationship this had with those DevOps things. So Dora, it's been going for a long time. I keep on saying a decade, but I've been saying that for several years now, so it's probably more than a decade. Loads of reports. We're very happy to sponsor this report because we think their work has been really rigorous and really cool. And the Dora community is a very cool place to speak to other people that are working this stuff out. So I hang out there and chat to people. And in terms of the first one, software delivery performance, 4 keys, 5 keys. You can see here, those pre-adoption people, kind of bottom end of the scale, their kind of median is just over 40. And then something interesting happens as you adopt a bit more GitOps, your median goes down. That's kind of weird, isn't it? So we adopt some GitOps, which is supposed to make things better. It makes things worse. But then when you adopt even more GitOps, it goes up and it keeps going up the more GitOps you do. And this is something that we call the J curve. And this happens with pretty much any technical practice. If you decide from today on, we're going to do test-driven development, what happens like initially is things get a lot worse. And then once you've learned it and you have some tests, things get better and you kind of recover it and then you excel. So we're seeing a J curve here, but high GitOps performers have higher software delivery performance. So more frequent deployments, shorter lead times, less failed deployments, faster recovery times. These are all cool things. Usually these are things that bosses want. So that's happy days. So didn't want to use the same chart for everything. So I've arbitrarily used different chart types to keep it interesting. So this chart shows 4 reliability measures. And again, these are the measures that Dora uses. So we have how satisfied is the end user? That's kind of important. Have your targets been met? And this is interesting because your targets will be different depending on the team you're on, the software you're working on, the organization. But do you meet your targets? How often do you meet them? We then have slowdowns. So how often does the system not perform as well as it should? And then we have outages. And I think we all know what they're like. That's when you get phoned up and you have to go and sort something out. And you can see here, pre-adoption and that low performance in GitOps are kind of competing to be the worst. So they swap, but you can generally see here, they're not doing so well. And then the kind of medium high performers are both doing actually pretty well against these reliability measures. So it does look like GitOps is helping with reliability. So that's kind of cool. And now this is the cool one. This is the well-being one. This is the one we're all interested in. Does it make us happy? And what you can see here is it's a kind of muted. If you look at the error zone, the kind of purple background, the happiest people at the lower end of the scale are kind of doing as well as the unhappiest people at the top end of the scale. So this isn't what we'd call the most dramatic finding, but there's a visual improvement in job satisfaction, lower burnout, those kinds of things. So that's good. So GitOps certainly isn't making you unhappy. It's probably making you a little bit more happy. Like you'd have to measure like how far are the corners of the mouth going up. It's cool. So now this diagram encapsulates all of that into those exact relationships. So which particular GitOps things affect those outcomes? The thicker the line is, the more of an effect that we saw in the data. Interestingly, given this is GitOps, it's worth pointing out, responsive code review turns out to be super important to this. Right, so there's all these cool GitOps things, declarative state and automatic reconciliation. But if your code review sits there for a week, that's bad news. And I think that makes sense, right? Because if I do a pull request to change the number of instances on my Kubernetes cluster, and it sits there waiting for approval, I'm probably going to go and use kubectl. I'm going to change the instances manually because that way it happens and then it solves my problem. So responsive code review is kind of a big driver of getting people to make their changes through version control, not directly on your cluster. So that's why we think that's such an important thing. Okay. Hopefully everyone's locked in now, the thickness of those lines. Just remember those. So, first question is, does it improve the DevOps outcomes? Yes, it does. It seems that GitOps and DevOps are best friends. They definitely have a good relationship with each other. Thank you, Elmo. But you didn't adopt GitOps in order to get the DevOps benefits. It's nice that you get them. That's a really cool bonus. The reason people told us that they were adopting GitOps was to get these things. So it'd be nice if people didn't access production infrastructure, right? Because mistakes can be made. And in my career, mistakes have been made. We wanted to improve compliance. That kind of makes sense. Auditability, who did what? Why has this changed? When did that happen? Is it the same time that everything stopped working? Drift prevention, and we all know what this one is. You set up a server, it's beautiful, you've got your cluster, perfect. And then you go and look at it a week later and it's unrecognizable because everyone's been kind of clicking around, doing stuff and running little commands, and they forgot a flag and kind of things go a bit nuts. So people wanted to know that the setup that everyone agreed when the architect sat down and said, this is what the cluster should look like, is still the configuration 6 months later, a year later. And increased security, because if everyone has to have like a special key so that they can go and access production infrastructure, eventually, you know, someone does a cool video of your new product launch and on a post-it note on the board behind them is the password for something. Bad news. And this chart basically shows the relationship across all of those factors. And you can see that in general, the more GitOps you do, the more you get the GitOps benefit, which kind of makes sense. Sometimes quite dramatically. So I don't know which one of these is the most interesting to you. Maybe find it on the list. Maybe it's drift prevention. A quarter of people managed to prevent drift without GitOps. It's kind of cool. Maybe they just have one person. All changes go through them. Everyone's happy. But if you're using the most GitOps, ticking as many boxes as possible, actually 90% of organizations prevent drift prevention. Not prevent drift prevention. I've used the word prevent too many times. Prevent drift. That is drift prevention. And here's another spaghetti diagram. So again, you can see the relationships between those input things and those output things. Crucially on this one, and this is an interesting one, we find a lot of people doing GitOps, but not doing automatic reconciliation, automatic pull, right? So they're kind of putting it in version control. They kind of like make all their changes through version control, but they wait for someone to go press at some point, you know, or when a change is made, it triggers through the CI process, then to kind of push that into our infrastructure. And that seems to reduce the benefits quite dramatically. So we definitely want to watch out for that one. So that's the one more thing now, right? Columbo always does this. He's just about to leave. And he goes, oh, there's just one more thing. Are you sure that what you're doing is actually GitOps? And this is what we found in the data, and it's quite dramatic. So we're going to start at the top of this graph. That's everyone. How many of them have got stuff in version control? Most of them. So there's a small drop-off of people that are like, no, we don't keep nothing in version control. It's cool. They probably keep their code in version control. We'll give them some credit, but not their infrastructure definitions. And then it's how many people keep it in a human readable format. Most people, very few people are using one of these binary formats where you can't really see what it's doing. I think that's a positive thing because you want to, if you're comparing to Git versions, it's nice if you can tell the difference. So, oh, that one is now 0. That can't be good. Then it's how many of them using declarative styles rather than imperative programming. Oh, there's a big drop off now. A lot of people are using imperative styles of programming with their GitOps, which means they've got code that says, go and get me from this API what that thing is. And then if it's not that, change it to be this, right? And so it's a list of steps. And then when it comes to that automatic pull, that continuous reconciliation, huge drop off. So by the end of this process, only 16% of people were doing that complete GitOps reconciliation loop. So that's definitely something to just bear in mind. Like if you're fearing switching on that final step, like just try it, right? Do it, because what's actually going to happen is you're going to have less problems and you'll be more secure and more auditable. So it'd be a cool thing. So all of these findings are available in this report, which you can download. It's free. Go and grab it. Enjoy the read. We also have other reports. We've got a great platform engineering report, and we're working on a new platform engineering report right now. So we have hired a PhD researcher called Dr. Charlotte Fleming. She's helping us to level up our research. She's definitely teaching me a thing or two in terms of that. I'm mostly just a Python guy. And we are also running a big software delivery piece of research at the moment. And we're very lucky to be working with Dave Farley, who is the one of the original authors of the continuous delivery book. And we want to find out more generally about software delivery. We'd love it if you could help us learn about that. You can choose to fill it in completely anonymously. You don't need any of your data to do it. You can put an email address in which case we'll send you the report earlier, but that email address is only used for our research. We don't pass it to anyone else. So you won't be inundated with sales or marketing or any of those things. So if you can find the time to do it, this is going to be a really cool report. So yeah, thank you very much. And I'm happy to take any questions people might have.
Thank you for the talk. I was already familiar with GitOps, and there's one thing that I'm always somewhat worried or even scared of, which is the reconciliation loop. I can't even remember the number of different ways the reconciliation loop, even if it's manually, has failed in the different ways. Let's say I made some changes to the GKE cluster. There's probably a million ways that it has failed, even when it's manual. I can't even imagine it being automatic, let alone integrating with other services. Do you think my concern is legitimate? And do you think that this is the biggest challenge to a proper GitOps deployment, GitOps integration?
Yeah, that's a really great question. And GitOps is not going to immediately solve any problems that you might have. A little bit like deployment automation didn't solve the DevOps problem on its own. There are other things that need to be resolved along the way. I think of it a little bit like you're lowering the water level and in a canal, and you have to remove rocks as you go. Okay, so sometimes you can lower the water level. It's fine, no rocks, happy days. Other times there will be obstacles in the way. There are some tools that help with some of these things. Like if you want to deal with applications or Kubernetes clusters, Argo, which is an open source project, is built for this. It was designed to do this exact thing. If you are using something that's like Terraform, you're going to still have all of the same issues that you have running Terraform anyway. And they will need to be resolved, and you'll need to gain confidence before you're like, yes, we'll switch it on. But the goal should be to try and get there.
Questions?
You mentioned not many people are using automated pull. Did you ask how many people were in highly regulated industries and weren't able to do that? There's a reason why they can't do it, right?
So yeah, we did. We were across 22 industries. Healthcare and insurance were in there. We always check, is there a big difference between industries? And we do this on the DORA research as well. The team always check this because that's often an objection. Like, can we really deploy more frequently if we're regulated? We don't find any particular problem by industry except hospitality.
Not even financial services.
No, we have financial services industries that are right at the top scores on GitOps. And I presume, I'm kind of speaking on their behalf, I don't work there. I presume that they actually find the audit trail from Git that shows all of the changes and their approval process in Git where someone approves that change to actually strengthen their compliance story.
I think certainly in banking, the people approving change aren't the guys that are approving PR requests. So I'm not sure. I think that might be a factor in some of your questions. The other thing is there was a sprinkling of security. It was nice to see because we got to halfway and there was no mention of security at all. But in terms of FinOps and costs, that is something that's bitten people over the last couple of years because they've been pretty free and liberal in letting their cloud guys deploy whatever they like. Is that something that's going to be more of a factor in this going forward?
Yeah, cost control is a really interesting one. And I think that's something that we're probably going to be surfacing a lot in the platform research as well, because platform teams, as well as taking on the whole complexity of the world already, now also getting cost control as being their problem too. So yeah, if you're a platform engineer, like, I feel you.
From the survey, how much did you find it was an issue on the individual solutions people were using for GitOps, scalability, that kind of thing? I know that you were at least loosely coupled into Argo, which has got some very famous scalability issues around performance, having to run a big infrastructure on your own and the rest of it. It's interesting, along with the fact that actually the GitOps industry, if you look at what the products that are in the space are doing, are actually going away from the auto trigger approach, where they do run CI/CD pipelines to build OCI artifacts that you then pull from, because you're then not reliant on the Git infrastructure and your CI/CD infrastructure that isn't promised to be available 24/7, 365. To the gentleman's comment about the financial services industry, it's always vaguely amusing that we've got teams on call that are meant to be 24/7 enabled to deploy straight away, but no one promises that the CI/CD system is going to be available for them at the time.
Yeah, and that's kind of crucial, right? Because if you are on call and you turn up and you're like, we need to roll forward a fix for this, but you don't have a build server available,
yeah,
that's a major problem. So yeah, Octopus is currently the top Argo contributor, but we're not kind of averse to other ways. Octopus itself is happy doing it more the CD way. Argo does it the GitOps way. When we looked at different tools, in terms of the performance, although Argo was more popular than Flux in terms of the number of respondents, Flux is not a terrible option, right? It's not going to be tripping you over. As you come out of the GitOps realm into some of the other ways of doing things, like there are other infrastructure automation tools that aren't GitOps by nature. You would have to call it and say, do a plan, do an apply. It may be more difficult to run those in that style, if that makes sense. Yeah. Yeah, and one of the things you need to watch out for with GitOps in general is all of these things are going to be calling back to your Git repo, right? So your Git repo kind of is much more important now, because all of these tools calling back, if you have a lot of instances that are all calling back to Git, obviously you could do a DDoS on yourself.
Same type of business that be a little bit run into a bit of a mess, just have a more upset change process. Still can't follow at their own place.
Yeah, and I think that one of the really cool things that you're saying there is that, and there's a book called Progressive Delivery that talks about this. We should be letting our users, the users of our software, participate more in the decision of when they take stuff. And I think we all know this, because when someone changes a UI that we use, it's like, where's the thing gone that I use all the time? It's just literally disappeared. So we want to bring the user in to participate in the decision of when they get stuff.
Steve, good evening. I'm over here on your right. There we are.
There's multiple microphones in play now. It's like, it's up the stakes.
Did your research or any of your other work reveal what are the obstacles to organizations adopting GitOps? How often is it, say, a technical issue or obstacles, such as they just have legacy infrastructure that won't play with infrastructure as code? And how often is it something else like cost or business logic or personal preference?
I think the answer to all of the stuff in tech is that it's a mixture of all of those. So we're locked in a system which is technology surrounded by people. So there's never going to be an easy, like, this is technically the correct answer, we're going to do it. Like, I've never been in an organization where it was that easy. I've been in organizations where the architect and the dev team, and they're like, well, a relational database makes no sense here. We should be using NoSQL, a document database. But then some central function is like, no, we're not going to support that. You can't do it. Right. And so now you're not dealing with a technical issue anymore. You're now dealing with the relationship building, the kind of like bringing them on side. And to be honest, with all of these, like, we've got CD, we've got GitOps, there's lots of techniques out there. Really, and we say this a lot in the Dora community. I don't know if you've seen the Dora core model, but there's loads of things called capabilities, which are just things you can do. There are loads of them on there, but the model isn't there to say, you must do all of these things. It's there to say, find out what your problems are and have a look on this list and see if there's something that might solve that problem. And that's the idea behind this. We don't really want to, in this case, GitOps is difficult to do 50% of. So if you're going to do GitOps, it's better if you can get higher up the scale. But in general, when you're looking at any of these maps, it's like, are we seeing this problem? Like, maybe we could try one of these things to solve it. It's like choose your own adventure.
Hi, Steve. Thank you for the presentation. As good as ever. And especially the last one, I think you did some time ago. Could you tell me, what sort of, in your research on Git, specifically GitOps wise, okay, what sort of, and from your surveys and your analysis, what have you found what's the most problematic issues that generally developers tend to come across or they hit their wall against, basically, that really need to be sorted out?
Yeah, so I think in general, through all of the research, not just our research, but research throughout the industry and stuff that's been going back to like Microsoft and IBM studies, batch size, they've been talking about that since the 70s. Smaller batches are just going to make your life easier. And this code review thing keeps coming up. So we found it when we were looking at GitOps, but they found that in other places too, because a slow code review, like what are you going to do if your code review is sat there for a week or 2 weeks? Either nothing, that can't be good, or you're going to start other work, and then that's making batch sizes increase. So I think batch sizes is probably a fundamental, crucial law of nature. We have to get them much smaller, and anything like slow code review that might make them bigger, we need to challenge it and see if we can fix it. So yeah, it's a super non-technical thing that we can look at. So.
Okay, I don't think we have any more questions on the floor, but I'm going to ask one just because I really like the points made earlier on. I've worked for the last 20 years in the industry deploying things in very big environments. I'm old enough to remember Puppet and Chef, and I feel like actually what we've done with GitOps is go back to that model. And actually, we know that the polling model doesn't scale well. We've already had talk about Argo and how well that controller handles it when you really get to big scales. All right, when you're small. But when you grow, actually, it becomes difficult. And actually, I feel very deeply that actually a push model is a far more efficient model and a lot easier to scale. I don't know how you feel about it and whether you've done any research on actually what is the difference between pull and push.
So this is kind of nuts and bolts stuff here. I think human systems, like, we kind of have things that we need and humans are involved. Humans should be pulling. I think that's a crucial thing. We all do better work when we bring the work towards us. When it comes to making the decision about something like, should we use the GitOps route or the CD route, which are kind of like, one is like that, pulling it and applying it. One is kind of triggered by something that we've done. Like, we're all working on really different systems. Like my last gig was websites for a car manufacturer, and we had massive scale in terms of the number of people visiting this stuff, especially if they ran a big campaign. But then the next system you work on could be like some incredible data crunching machine. And it's like, so there's so much context. Our job is to work that out with our very specific situation, if that makes sense. So in a way, your expertise will help you make those decisions. And what I would recommend is watch out for the problems, right? So if you're using a pull model and you're overwhelming your Git server, you're like, okay, what is it because we've chosen the wrong path, or is it because we need to just beef up some tech, and vice versa? So if you're pushing and you're seeing problems, so it's sensing the problems and then responding to those.
Yeah, like I said, I think that was my point. Actually, when you do scale, you hit both of those problems. Actually, a number of different problems you hit. Actually, I think it's a regression in terms of promotion of build and build versioning. So what I tend to see, which I think is a flaw, is people use files and pin versions in files. And so your CI/CD is not then versioning a build that's a dependency and then promoting that into the next build to be used so that you get live updates. And that actually causes your inability to like produce a version, and then you use things like Dependabot to try and like then solve that problem, and then it gets more and more complicated, and you use all of these different things to manage the problems that just wouldn't be there if you just used a push model.
Yeah.
So yeah. Anyway.
Yeah, I also think as well, we sometimes choose the wrong models. So it's quite common for someone like Facebook to share how they do development, but their problem is they have so many developers that you couldn't put the changes through sequentially. So they've come up with a way of like, 100 people are all committing almost simultaneously. How do you actually run CI and CD for that? But don't try and base your model on that if you're a team of 100 or 1,000, because you're not at that scale.
Actually, I don't think the two things equate. And the way that the way that Facebook create a release branch and then merge in and out the changes, whether the chatbot says that the person is there to support their change or not, is entirely probably not the most amazing way to do it. But let's not talk about them. Anyway, I think
it's working for them. That's cool, but don't copy it if you're not like them, because we do it with a lot of organizations where we're like, that organization is cool and they've shared some information about how they do it, but it's not necessarily appropriate for our organization and our team size. So
just in terms, we'll have this conversation with a beer in a minute.
Yeah.
Just in terms of the talk, thank you so much. It was really, really interesting, and a round of applause for Steve, please.
Thank you very much.
Yeah. So, I believe we do have Chronosphere here now. We do, yes. Excellent. Let me just put this slide up there. Just come on. Here we are.
Thank you. All right. Hey, everyone. So, yeah, my name's Rob. I'm a lead solutions engineer at Chronosphere, who are now part of the Palo Alto Networks umbrella. I wasn't planning to give an announcement today, but happy to do so. So just to give you a bit of background on Chronosphere, we have been in the leaders part of the Magic Quadrant since inception. We are the fastest growing observability company, and we support all of the melt telemetry, so your metrics, events, logs, and traces. And how we differ from other observability platforms, essentially 3 key areas. We take an open source first approach to data collection. So think Prometheus, open telemetry, whatever open source frameworks you're using, you could ship that telemetry to our backend, and then we'll weave together that context server side. And obviously that's focused on completely eliminating vendor lock-in. Our AI-guided troubleshooting, so all of the telemetry that's persisted in our backend, that would be ingested by our AI, which is a continuously learning temporal knowledge graph, again, traversing across all different telemetry types. And that is all about identifying the root cause of incidents automatically and driving a faster mean time to resolution in general. And then also our control plane. So that's all about identifying noisy telemetry and then stripping away that noise. And that's driving a reduction in telemetry bloat and also providing cost control as well. So yeah, that's a quick high-level overview. I bought 10 physical copies of our book today. So I'm down to my last 6. I walked through the door and I've lost 4 already. So come and grab me outside, and yeah, all in return for an email address. That's it. Thanks very much.
Okay, and I think that wraps us up for tonight. So thank you, everyone. It was a really interesting couple of talks, and hope to see you again next month. Thanks again.